So why we are using this is because in order to find the test-retest reliability, we have to use Spearman-Rowe correlation. So Spearman is named after Charles Spearman, and we can see one letter here, like it is looking like P, but it is actually called as Rho, or it is sometimes called as RS. So it is a non-parametric measure of statistical dependence between two variables. So this letter indicates Spearman-Rowe, and this assesses how well the relationship is between two variables, and it can be described using a monotonic function. Monotonic function means non-increasing or non-decreasing. So which means having a property either of never increasing or never decreasing. So in a monotonic function, it is a function in mathematics that receives the given order. And in the case of Spearman-Rowe correlation, if there are no repeated data values, a perfect Spearman correlation of +1 or -1 occurs when each of the variables is in a perfect monotone function. So the range is like +1 or -1. One minute. Yeah. And we can see Spearman rank order correlation. It's a formula here. So in order to test the test-retest reliability, we can either use Spearman or Wilcoxon Sine rank test. We will show you the application of both today. So in the case of Spearman rank order, this P kind of sign is called as rho, where it is actually known as Spearman's rank correlation coefficient, and n is the number of observation, and where di, which we can see here, it is the difference between paired ranks of each observation. And we have some assumptions to do this test. That means two variables should be measured on an ordinal, interval, or ratio scale. So we know what is ordinal scale. It will be categorical. That means we will have ordered categories and distance won't be known in the case of ordinal. But in the case of interval, we know the distance and there will be equal distance. In the case of ratio scale, it will be having same property as the interval, but there will be an absolute zero. So that's one assumption is that. Next one is two variables represent paired observations. Then there is a monotonic relationship between two variables. So these are the two assumptions needed. And this is how we will do the application. That means how we will do the Spearman-Rowe in Excel. This is only just for understanding. We will be first, this is not the test-retest data. This is just for just an example for understanding. So here we can see physical activity, then we can see blood pressure. So these are the two kinds of data, and what we are doing here is we are assigning ranks. For the physical activity, we can see ranks are given. Then for blood pressure, we can see ranks are given. Then we have found that D is the difference. Then D2, that is the D square. So 8 into 8, here comes 64. Then the Spearman correlation is found there. That is negative 0.75. Here indicates a negative correlation. So this is just an example to show you how it will look like. And the interpretation of Spearman will be like this. That is, here we have given the range and the strength. The range will be 0.00 to 0.20 will be negligible. 0.21 to 0.40 will be weak. 0.41 to 0.60 will be moderate. 0.61 to 0.80 will be strong. 0.81 to 1 will be very strong. This is how we interpret the scores. So we will show you how this application is. Anushree will show you the calculation, then it will be more understood. Anushree, can you start?
Yes.
Okay.
Is it visible?
Yeah, it is coming. It is not visible, but it is coming.
Now?
No.
Now?
Not yet. I think you just stop share and then do it again. Then it will.
Hmm. Now is it visible?
No, it isn't.
Now?
No, it is not coming.
I'm
It shows.
leaving, then I will rejoin. 1 minute.
Okay. Please wait for 2 minutes. Roman, is the theory part clear for you? Roman, are you there?
Hello, is it visible?
No, it is not. Are you sharing the screen right now?
Yes.
Okay, okay.
Is it?
No, it just came and go. Just it just flashed and left.
Now?
No.
What can I do now? What's the problem?
Yeah, it just came, then it disappeared.
Still, it's not coming.
It shows you are just sharing it, but it is not coming. What is the issue?
Is it visible?
No.
Now
Yeah, it came.
it is visible.
Yeah, it is visible.
Okay, thank God. Okay. I will show you the test-retest reliability through the Spearman rank order correlation. Here we can see can you see the data set? Everyone please respond. Can you see the data set?
Yes, it is visible.
Okay, the data set indicates there are 8 individuals, A, B, C, D, F, G, H, and their rating data with respect to each values. For self-awakening, there is 4. For the A, that is emotional control, that is 3, like that. So we are just showing you, as the sample size is very small, we are just doing the Spearman rank order correlation. Otherwise, if the sample size is large, then we can do the Pearson's correlation, Pearson product moment. But for this smaller sample size, we are doing the Spearman rank order. So we will show you item-wise rank. So for the self-awakening, you get this is the data for the attempt 1. That means attempt 1, you can see, that means it is the data of the first test. And here, this is the data of the second test, that is the data of the retest, that is attempt 2. So I have to find out the correlation between the attempt 1 and attempt 2. So I will do equal to, then I will select this cell, enter, so I get this value. I will just drag it down to get all of this data. I'm writing here A, B, C, D, E, F, G, and H. So these are the data for the self-awakening. I have to do the rank. I'm writing here A1, that means attempt 1, the data for the attempt 1. Now I am writing R1, that is the rank of this attempt 1. You can see here there are 4 is here, 1, 2, 3, 4, 5, 6, 6 times 4 is there.
And there's a lot of disturbance in the background.
I think someone is opening that. Please unmute. mute yourself. Sorry, mute yourself. Sir. 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 Okay, we will do the rank. So there is 6 times. There is 4, 6 times. So we will have to do 1 plus 2 plus 3, 4, 3 plus 4 plus 5 plus 6 by
Ma'am, you are
6.
not audible.
Hello?
We can't hear you clearly.
I think someone is unmuted themselves. Sir? Sir?
Hello, I cannot listen to the sound.
Sir, can you mute yourself? Because the background noise is
Hello, I
there.
cannot get any sound. That is the problem.
Sir, can you mute yourself?
Hello.
Rose, please ask Sir to mute himself because we can't understand and he also can't see.
Sir,
Hello,
can
please
you-
write in the chat box. I can follow.
Yes, sir, I'm writing.
Yes.
I think sir left.
Okay. I'm going to show you. I have some issues with network, I think. Okay. So there are 6 times, 4 is there 6 times. So we have to compute the rank as 1 plus 2 plus 3 plus 4 plus 5 plus 6 by 6. Okay. So it will be 3.5. Is it clear? The ranking? I think you know the ranking. So the 3.5 will be for all the 4. Now we have completed up to the 6th position. Then we should compute from 7. So there is 5. 2 times there is 5. So 7 plus 8 by 2. The rank of 5 will be 7 plus 8 by 2. That is
Sorry,
7.5.
it's not clear. It's not clear.
Okay. Listen. We have to do the ranking on the basis of their score. Okay. Is it clear? We have to do the ranking on the basis of the score. So the score that is lowest, that will get rank 1. Higher than that will get the rank 2 like that. But whenever we have got the rank that is, got the score that is not here once, we have to calculate just like this. We have 4 here, that is the lowest point, that is the lowest score. Isn't it? 4 is the lowest score here. Hello?
Yeah.
4 is the lowest score, so we have to provide the first rank to it. But there are 6 4s. 1, 2, 3, 4, 5, 6. There are 6 4s. So we have to do 1 plus 2 plus 3 plus 4 plus 5 plus 6 by 6 divided by 6, because 4 is there 6 times. So we have to divide it by the 6, and as it takes 6 positions from 1 to 6 positions, so we have to calculate 1 plus 2 plus 3 plus 4 plus 5 plus 6. Is it clear now? Is it clear? Hello.
The position is not clear, you know. How do you get 3.5? How do you get?
Okay. This is the lowest score, that is 4 is the lowest score, but 4 is there 6 times. So 4 takes 6 positions from 1 to 6 positions. Clear up to that?
Yeah, yeah.
So we have to calculate like 1 plus 2, sorry. One plus 2 plus 3 plus 4 plus 5 plus 6 equal to 21 divided by, as the 4 is there 6 times, so it will be divided by 6. That is 3.5. Okay. Is it clear? 4 is there, that is the lowest point, and
Yeah.
it is there 6 times. So and so it takes 6 positions from 1. So we have to sum up 1 plus 2 plus 3 plus 4 plus 5 plus 6. That is equal to 21. Then as it takes, there are 6 times, 4 is there 6 times, so we have to divide it by 6. That is 3.5. So we have to put 3.5 for all the 4. Okay. Is it clear now?
Yeah, yeah, yes.
Okay, so 4 takes up to 6 positions. Now we have to rank the 5. So then we have to calculate from 7th position, because 4 takes the 6 positions. So we are now calculating 7 from the 7th, but 5 is also there twice. 5 is also there twice. So we have to do what? 7 plus 8, because 5 also takes 7th and 8th position. So you have to sum up 7 plus 8 by 2, because 5 is twice. Okay. 7 plus 8 that is equal to 15. 15 divided by 2, because 5 is there 2 times, so that is 7.5. Likewise, we have to do the rank. Okay, is it clear up to that? Is it clear?
5 is on the position of 7, you mean? Number
Yes,
5.
yes.
Number 5 is its position is 7, you mean?
Yes. 5, the position is 7 for the 5, and there is 2 5, so it takes 7th and 8th position. Clear?
Which one is the 8th position? Which one?
If this is the 7th position, it's 8th position, then we have to calculate, we have to put the same rank, no? So because the score is same, so we have to do 7 plus 8, as the 5 is twice there, so we have to divide it by 2. 7 plus 8 for 5 because it takes 7th position, it takes 8th position. So 7 plus 8, that is 15. And if as it is there 2 times, so we have to divide it by 2. That is 7.5. 15 divided by 2, that is 7.5. So we have to put 7.5 for all the 5. Clear?
Yeah.
Okay. Now I will write it down. A2. I have to select the data from the attempt to self-awakening for this correlation. So I'm taking it. I have selected, then put enter. I got the score, then I will drag it down. So I will get all of the scores for all the individuals for attempt 2. Now we have to do rank again. So R2. What is the lowest score here? This is also 4. And how many 4 is there? 1, 2, 3, 4, 5. 5 4 is there. So what will be the rank? Please tell me, someone. Four is there 5 times. So 4 takes first position to 5th position. So it will be 1 plus 2 plus 3 plus 4 plus 5 divided by 5. Clear? Clear?
Yeah.
Okay. It is 3. So we will put 3 for all the 4 because the rank is 3. So it takes up to 5th position. So the 5 will start from 7th, 8th, and 9th. So 7 plus 8 plus 9 divided by 3. Clear? One, two, three, four, 5. Is it clear? Hello?
Yes.
It takes 6 times, it takes 6th, 7th, and 8th position. Sorry. 4 takes up to the 5th positions and 5 takes from the 6th. So it is 6th, 7th, and 8th position. So it will be 6 plus 7 plus 8 divided by 3. That is 7. Clear? Now we have to do the difference between them. That is D. So equal to, I will select this rank 1 minus, I will select the rank 2. Enter, that is 0.5. So I got the difference between rank 1 and rank 2. Likewise, I will drag it down. So I will get all of those differences. Clear up to that? Clear? I'm finding out the difference between the rank 1 and rank 2. Clear?
Yes.
Please, okay. Now we have to calculate the d square. So I will put equal to, then I will select it, then shift 6 to enter. I got this square. I'm just squaring the d. I'm dragging it down, so I have got all of this d squares. Clear? Is it clear?
Yes.
Yes.
Okay, now I have to do the sum of d square. Because I have to put it into the formula of rho, that is 1 minus 6 summation d square divided by n into n square minus 1. So I have to find out the sum of d square, that is equal to sum. I have to select the cells, bracket close, enter. I got the total of the d square, summation d square, that is 46. Okay? Clear? Please tell me.
Yes.
Okay. Now I have to put into the formula. So what is the n? What is the n here? How many participant is there? N means sample size. How many participant is there? A, B, C, D, E, F, G, H, 8.
8. Huh?
Yes, n equal to 8. So we have to do n into n square minus 1. We have to find out n into n square minus 1. So it will be 8 into n square is 8 square. That means it is 64. Right? 8 square is 64. So it will be 8 into 64 minus 1. That is 63. So 8 into 63. That is 504. So n into n square minus 1 is equal to 504. Now I have to put it into the formula, that is 1 minus 6 summation d squared by n into n square minus 1. I have this summation d square, I have this n, I have this n into n square minus 1. Now I have to calculate I have to put it into the formula, that is 1 minus 6 into summation d square, that is 46, into 46 divided by 504. That is 0.46. So the correlation is 0.46. That is not very good correlation, but this is the moderate level of correlation. So we get the correlation between the test and the retest. We have done it with the self-awakening, path-oriented self-awakening, self-awakening attempt 1 and the self-awakening attempt 2, and the correlation coefficient is 0.46. Clear up to that? Clear?
Yeah.
Okay, likewise, you have to do all of those Spearman rank correlation for the other values. I am only showing to you the self-awakening, and you have to do all of those. Is it clear up to that? The procedure. Any doubt? Hello?
Would you repeat how you calculate the position? For example, the second one, the second item, A2.
For A2. Okay.
Yeah.
You have okay. Okay, there is the score that you have find it out that there is 4. 4 is the lowest score here. 4 is the lowest.
Yeah.
And 4 is there 5 times. 1, 2, 3, 4, and 5. 4 is there 5 times and it is lowest. So it will be start from 1 plus 2 plus 3 plus 4 plus 5 divided by 5 because 4 is there 5 times. And it takes from first position to fifth position. So that will be 1 plus 2 plus 3 plus 4 plus 5 divided by 5, and that is 3. So I have to put 3 for all the 4.
Sorry, here you are adding all the 5 fours or what? You are adding 4 plus 4 plus 4 or what?
No, no. I have to calculate the sum of the positions like that. Okay. 4 is there first time. 4 is there second time. 4 is there third time. 4 is there fourth time. 4 is there fifth time. So I have to do it 1 plus 2 plus 3 plus 4 plus 5. Okay. So it is equal to 15, and then I have to divide it by 5 because there is 5 times.
My question is, thank you. My question is, the second 4, the position of the second 4 is on 3, not on 2. My question is that,
I can't understand. From
the first position there is 4, and next the second position is 5. Why you say 4? The second position is number 5. Is that not?
No, it is not like that. You have 4, and 4 is the score that is below 5, and then you have to collect all the 4 first, then you will go for the 5. Clear?
Okay.
Clear?
Yeah.
This is the case. After considering all the 4, you will go for 5. And if there is 6, then after considering all the 5, then you have to go for 6. Okay. So the position matters and the value also matters. 4 is there 5 times. So we have to collect all the 4 first. Then I will go for 5 because 4 is the smaller one. No? So you have to collect all the 4 at first, then we will go for the 5. Is it clear?
Yeah, it's clear. Thank you.
Okay. So I am showing you the correlation coefficient for the self-awakening, and your assignment is to do the correlation coefficient for all the values, that is from emotional control, systematic, self-insulting, all of those things. Okay. Now, Rose, please continue with the Wilcoxon.
Yeah. So we have seen Spearman. Now we will learn Wilcoxon sign rank test because Wilcoxon is also used to.
I wanna add one thing.
Yeah.
Rose. Yes. Actually, we are trying to measure the correlation coefficient in order to measure the reliability. But this is the Wilcoxon is not for that, but we will cross check it, because if we try to make a scale, make a test, a psychological instrument, we have to check whether there is a good reliability. So whenever we are trying to check the test and the retest reliability, we are expecting there should be high correlation between the first test and the second test. Okay. So if there is the high correlation, there should be less difference between the scores of the test and the retest, isn't it?
Yeah.
So we are finding out the difference between the scores with the Wilcoxon, because we are just cross-checking. If there is a good correlation, there should be less difference. For that purpose only, we are trying to measure the difference between the scores, and so we will show you the Wilcoxon. Okay. Actually, we are testing the correlations for measuring the reliability. And we will cross-check. There should be less difference between the test and retest. For that purpose only, we will show you the Wilcoxon. That is the point. Okay. Rose, you can proceed.
So Wilcoxon sign rank test, it is another test that is a non-parametric equivalent of one sample t-test. It is most commonly used to test for a difference in the mean or median of paired observations. What we are showing you today is a Wilcoxon matched pairs sign rank test. It computes the difference between each set of matched pairs, then follow the same procedure as the sign rank test to compare the sample against a median. And it is used to compare two sets of scores that come from the same participants. And we have some assumptions for the Wilcoxon test, that is the dependent samples. That means the two samples need to be dependent observations of the cases. And if independence, it is another one. The Wilcoxon sign test assumes independence, meaning that paired observations are randomly and independently drawn. And next one is if continuous dependent variable. That means although Wilcoxon sign rank test, it ranks the differences according to their size and is therefore a non-parametric test. It assumes that the measurements are continuous in theoretical nature. Next, the fourth assumption is if ordinal level of measurement. That is, the Wilcoxon sign test needs both dependent measurements to be at least of ordinal scale. This is necessary to ensure that the two values can be compared. This is the formula of the large sample. That means in the case of large samples, we will use this formula. Here the W is the test statistic, SGN is the sign function, X1 and X2 is the corresponding ranked pairs, and Ri will be ranked. So there are different formulas for small as well as the large sample. So here this is the formula for the large sample. In the case of large sample, we have to find the Z value in W. Then in the case of small samples, we will find the T value. Here we can see the procedure of Wilcoxon. So in the first step, for each matched pairs, we have this matched pairs. So in each matched pairs, we will determine the sign difference, that is DI, between the two scores. Then we will rank these DIs without respect to sign, without giving the sign. And then if there are tied Ds, then we will assign the average of the tied ranks. Then next will be affixing the rank sign, that is plus or minus of the D which it represents. Then in the this T is determined. I have discussed it before. That is T value is for the small sample, and in the case of large samples, we will see the Z value. Now, then in the procedure of determining the significance of observed value of T, it is given that it depends upon the size of n. That means if the sample size is 25 or less, that means it is a small sample. And if the sample size is larger than 25, that means it is a large sample. So this is how the calculation is, and we will see its application. So here I have mentioned again that small samples we will find a t-value. T-value in the sense it is either the sum of the positive ranks or the sum of the negative ranks. So this is what t-value means. And this is the appendix part. That means how the interpretation is about. Interpretation is based on the sample size, that means n, and we can see the level of significance given here 0.25, 0.05, 0.02. So this is based upon the n, that is the sample size, how we determine the values. Now Anushree will be showing you the calculations of Wilcoxon.
Yes, I wanna tell you everyone, please take a screenshot of this last appendix table. Aruz, can you share?
Yeah, I'm sharing.
Yeah. Everyone, please take a screenshot of this table. It will help you now. Is it done?
Yeah.
Okay. Is it visible?
Yeah.
Okay. So now I will show you the Wilcoxon. To test if there is the difference between the test and the retest or not. For that purpose, I will accumulate all the values for each individual. Like we have the 14 values under the path oriented. So I will add all those values for the individual A. For the individual B, I will add all of those values for the path oriented. So here equal to sum. I will sum of all those. So I'm selecting all the path oriented values for the individual A. Clear? Enter. So I got the total, that is 49 for the individual A. So I'm write it down. Okay. So I will just drag it down. So I have got all the total. Clear up to that?
Yes.
So I'm writing here path 1. That means this is the total scores for each individual for the first test. Okay. Now I will write down path 2. So I have to calculate the sum for the attempt to for all the path values of each individual. Equal to sum. Now I have to select from this to this. Bracket close, enter. So I got the total for the path 2 for the individual A. That means the path oriented values total for the retest. Now I will drag it down so I get all the scores for test and the retest. Clear up to that? Clear?
Yes.
Okay. Now I have to find out the difference between path 1 and path 2. Okay. So I will do equal to I will select this path 1 minus I will select this path 2, enter. So I got the difference, that is minus 1. Here. Now I will drag it down so I got all the differences. Here. Is it clear? Hello?
Yes, yes.
Okay. So this is the D. Now we have to do the rank of this D. Rank of D. So what is the lowest score here? Forget about the sign. Just follow, just focus on the value and tell me what is the lowest score here.
1.
Yes, 1. How many times is there? 1.
It's 2. 2.
2 times. So it will be 1 plus 1 divided by 2. Sorry, 1 plus 2 divided by 2. Clear? That is 1.5. So 1.5 will be for all the 1. Here. Now what is the second lowest score?
It's 3.
Hmm?
3?
3. And 3 is there 1 time.
Yeah.
And 1 takes up to the second position. So it is about 3. Clear? Clear?
Yeah.
Okay. Now, what is the next? What is the next?
5.
5. 5 is there once, so it will be just 4. Okay. 6 is there once, so it will be just 5. 5th position, so 5. Then what is the next?
9.
9. So it will be 6. Then
10.
yes, it will be 7. And then this is the last one, it will be 8. Here, here.
Yeah.
So we have done the rank of the differences and we just only put the sign before that. Sign indicates direction only. Now we have to do sum of the positive ranks and sum of the negative ranks. So I am writing it R plus, sorry, R plus, that means summation of all the positive ranks. And I'm writing it down, that is R minus, R minus, that means summation of the negative ranks. Here you can see that is minus 1.5, so it will be not there. Only 6 is their positive rank. So the summation is only 6. Clear?
Yeah.
And now we have to just calculate all the negative ranks. There are so many negative ranks. That is 1.5 minus 1.5 minus 8 minus 3 minus 1.5 minus 4 minus 5 minus 7. So we have to do sum. So that is 1.5 plus 8 plus 3 plus 1.5 plus 4 plus 5 plus 7, that is 30. So the sum is 30. Okay. And the sum for the positive rank is 6. Clear? Clear up to that?
Yes.
Okay. Now, as per the rule of the Wilcoxon, we have to select the data, select the score, that is the small, that represents the smaller rank. Okay. So here the positive rank represents the smaller one, that is 6. So we have to select 6 only. So the T statistics for the Wilcoxon is 6. Okay. Is it clear? This is the rule for the Wilcoxon, that we have to sum up the positive ranks and the negative ranks separately, and the smaller rank will be the result for the Wilcoxon. Okay. Clear? Hello? Hello?
Yeah.
Okay, so we will just focus on the 6 because this is the smaller rank. So our T is equal to 6. Now we have to check the table value, and our sample size is very small, that is 8. When the sample size is smaller than 25, then we have to calculate the t only, and when it will be higher than 25, we have to calculate the w. We have to find out the z score first, then we have to do the w score. Now our sample size is very small, that is 8 only. So we are only just computing the t, that is 6. And we have to check the table value. Let's go to the table. Do you take the screenshot of this table?
Table is in the group also, you can check.
Yes, please check the table. And the sample size is 8 here. So check the n equal to 8. What is the scores in the table? For the n equal to 8, what are the scores? Check for the 0.05 level. And tell me. Tell me what is the score for 8, n equal to 8. What is the score for the 0.05 level? Anyone?
Zero?
For the 8, for n equal to 8,
Uh, uh, under 0.05, it is 4.
0.05, under 0.05,
4.
it is 4. Yes,
Yeah.
it is 4. And we got the result, that is 6. That means it is, that means the table value is lower than the observed value, and the observed value is the higher than the table value. And as per the rule, if the observed value of t is equal to or less than that given in the table for a particular significance level and particular n, null hypothesis will be rejected. What is our null hypothesis for this Wilcoxon? The null hypothesis is that there should be no significant difference between the test and the retest. Okay. That is our null hypothesis, that there should be no significant difference between the test and the retest. And the alternative hypothesis is there should be difference between the test and the retest. Okay. Clear? Because we are finding out the difference between the test and the retest through the Wilcoxon. So the null hypothesis indicates there is no significant difference between the scores of the first between the test and the retest, and the alternative hypothesis is that there is a difference, significant difference between the test and the retest. Okay. Is it okay?
This t is equal to 6. What indicates? I'm not understanding.
Yes, I'm telling. So, Rose, can you show the
PPT.
the paragraph? Yes, the PPT. Okay. So they can understand.
1 minute. Which one?
The before that, yes. Okay. Please, anyone, please read it. Please read it, you can understand. Read it. This if n is 25 or less, read it down. Please, someone, please read it. Roman or Anindita, who is there?
Okay. If n is 25 or less, table G shows critical values of t for various sizes of n. If the observed value of t is equal to or less than that given in the table for a particular significance level and a particular n, this I have alternate hypothesis. Yeah, hypothesis may be rejected at that level of significance.
Yes, that means if the n is 25 or less and we have the n that is 8 that is lesser than 25. So we have to consider the table G and Rose, please. So if the observed value of t is equal to or less than that given in the table for a particular significance level and a particular n, null hypothesis will be rejected. So our t value is higher than the table value, isn't it? Here it is written that if the t value, the observed value of t is equal to or less than the table value, then the null hypothesis will be rejected. Clear up to that?
Our
value is higher than the table value. That means we will accept the null hypothesis. Clear?
Our value is 6, is that?
Yes, our value is 6 and that is greater than the table value because the table value is 4 and we get the observed value that is 6 that is greater than the table value. So we will accept the null hypothesis. We will not reject the null hypothesis. We will accept the null hypothesis. Clear?
Yes.
So if we accept the null hypothesis, what does it mean? Our null hypothesis is that there should be no significant difference between the test and the retest. And if we accept the null hypothesis, that means in our data, there is no significant difference between the test and the retest. So this is expected because we are finding out the relations between the test and the retest. We are finding out the test-retest reliability through correlation. So there should be high correlation between them. That is our expectation. And we also find out by cross-checking that there is no significant difference between the test and the retest. That means it is good, isn't it? That means we are getting the similar type of data for the first attempt and the second attempt, for the first test and for the second test because it was taken on the same sample. As the data are similar type of, so we don't have the scores that is significantly different from the test 1 and the test 2. Clear?
So we accept the alternative hypothesis, you mean?
We will accept the null hypothesis because our score is higher than the table value. Null hypothesis means there is no significant difference between the first test and the second test. And that is our expectation because we are finding out the test-retest reliability. We should have the data. There should be high correlation between the first test and the second test because it was taken on the same sample. So our expectation, there should be high correlation. If there is a high correlation, there should be less difference. Isn't it?
So here we couldn't get high correlation, you mean, now?
No, we get high correlation. For that reason, the significant difference is not there. we are accepting the null hypothesis that there is no significant difference. That means the difference is less for our data. That means that is good. We are finding out the similar type of data for the test and the retest, so the difference is less. Clear?
Okay.
Okay. Any question? Is it clear up to that? Hello?
Clear.
Okay, so we can stop it. Sir, are you there? Sir?
Hello.
Yes, sir, we have done.
Oh, thank you. Thank you. So, what is the assumption? If there is a high correlation
There
between the
should
two
be
sets
less
of data,
difference.
between the two sets of data, trial 1 and the trial 2, okay, then
There should be less difference between the scores of the trial 1 and trial 2, and our result is also that.
yeah, I think this is clear to all of you. Hello, is it clear to all of you?
Yes.
Okay. So when we are finding out the significant difference, then what is the meaning of the significant? Why do we study the significant? What is the meaning of the significant? Significant means we are able to generalize that data. We can generalize the data to the population. So if we collect the more number of data, possibly we will get the same type of information. For that reason, we are applying the significance. So your test-retest reliability chapter is closed. So it is very clear to all of you. Okay, so three things are there, three statistics are there. One is the correlation statistics, when your data follows the parametric approach, and when your data size is good, that is the data is the large data, then you can apply the correlation. You can apply the T statistics if your distribution follows the normality, okay? And you can apply the Wilcoxon Sine test when your data, your sample size is very small, number one. And number two, that is there is the distribution has some skewedness. So distribution does not follow the normal distribution, then you can apply the Wilcoxon Sine test. Okay, thank you.
Thank you, sir. Thank you, sir.
So you are lucky, all the students are still with you. It is 9:30. Students are very good. They are very sincere. They are trying to learn all those things. Thank you. Thank you, everybody.
Thank you, sir.
Show fault.
Thank you, sir.
Thank you. So I am closing.
Yes, sir.
Okay.